We are live. There was a technical problem. Let me change the titles. Edit. Path finding algorithm in Rust. Okay. Save and again. Save. Okay, let's go. So first of all, actually we need to think about something that is more useful. We need a way to test some possible ways, like some possible game states. And for this, we need to parse some string data that's taken from files, right? Or this is just for simplicity of the testing. So we need to make testing possible in a way that is easy. So let's think about this. In the implementation, how can we do, like, is there any? Oh yeah, we can use this one. So top and yeah. So this is going to be, I guess, 1, 2, 3, and what? Yeah, 1, 2, 3. This is, I guess this is complicated. Can we instead use just x's? Like, think about this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, my battery's going low. So wait a second. Okay, I guess we are just fine. Let's see. Just a small change here and there. Oh wait. No. So that's it. Okay. 10, and we will have 10 columns. Ten to 10. Okay, this is 10 to 10. And player 1 is going to be 1 and player 2 is going to 2. Okay. So we can just use space. Wait. Oh, okay. And we can use spaces. Yeah. 1, 2. I guess this is the best way. But let me just try to implement this in my mind. 1 and 2. Okay. So by the way, there will be 9 to 9 lines, so just Let me change this one. Yeah, just like that. Vim would be a better choice here, I guess. 1 and 2. Okay. We could also use 2. So, in this example, if we see 1 or 2, add user to the corresponding node. Okay. Or actually 1 create node and add user1 value. 2 create node and add user2 value. X create node. New line. Go to new line that we will implement in some way that I'm not sure about. And also let's think about borders. Oh, by the way, space continue. So space is nothing, actually, this is better. And if we see this, but okay, how can we implement like this? So let's think about this more. Is there like actually seeing this one do nothing, right? Bottom and up. What is the best way possible to easily see what we are doing and at the same time implement it in code? Oh, I couldn't find any way. So left is going to be this. So how do we implement top? Let's think about this way. dots, maybe. Top, bottom. No. X. Top, T. So yeah, we could, oh, let's think about this. So if spaces mean nothing, then we can do something like this. Right? What is the best way to show this? Still, I'm thinking. Maybe this is the way. Or this is better. Yeah, this is just better, I guess. In this case, if we see a space, make current node null, do nothing else, or just do this. So we will have a cursor. Do this cursor, or let's say none, because we are a rusty guy. Right. So okay. Oh wait. Okay. So we can start by implementing this one, which I think is a good point to start. Okay. Before starting out with this one, let me just go to bathroom, and I'm going to make tea. So 5 minutes break for everything. I'm coming back. I'm back. He's getting ready, and I'm going to take care of it in a second. But let's just start off with creating a project So okay, cargo new labyrinth. I'm going to call this labyrinth like this because labyrinth game is something else. Labyrinth elk. Parser .rs mod parser. Okay, and pub function parse. And let's also have a actually I don't know how to use like what was name lib and main at the same time. Rust use lib and main at the same time. librs fan hey that prints that prints hey. So how do we use hey? Create hey or what? How do you do this? Oh, pub function, of course. Hey. Oh, we can use hey. So why do you not implement? Okay, it does it. Okay, so we are going to define node, or not node, pixel maybe. Pixel is a better name here. Left wall boolean, right wall and bottom wall. Okay, it's going to be public and these bad stuff. So next up, let's see. We have these we are going to define impl pixel from or parse from what? Parsed from string or str maybe. Yeah, which takes data, which is going to be a string, and it returns a pixel, of course. Mismatch type pixel font. Yeah, okay, you are right. And actually let's create a function new that will return a pixel and return pixel with left wall false, right wall false, bottom wall false. Okay, for now let's return pixel new, and this is all. So we need to define a match, or actually let's take a look at something like this. Let's pixels. By the way, this is not going to return a pixel. This is going to return board. Pub struct board. So okay, and board is an array of pixels. Like, it's going to be a 2D because it's a board, if you think about it. And I think we should not use vectors here because a board is going to be 9 to 9. It's like, it's a known thing. So how do we create wait a second, my tea is ready. I'm coming in a second. Yeah, we are back. So let's see. It gave me a warning, by the way, that we should implement a default, and it makes sense. Yeah. So here, the default. Okay. Pixel default. Let's just close this one and return pixels syntax error. Yeah. So in case of simplicity, we are going to create a type called row, which is equal to an array of pixels. How do we do this? Yeah, I think this is the way. Okay. 9. So 9 pixels, right? And we are going to implement nothing for pixels that we are going to implement board at this point. Board rows is going to be like what? A pixel 9, or actually wait, a row of 9, right? Yeah. So this changed nothing, but it's still actually this changed nothing, so we didn't need that, but I'll keep it. I'll keep it. And this implementation will be for board, and this will return a board here, pixel default board. Can we implement default for our board? I guess yes. Deriv default, so board, default board, and board. Yes, we can. Necessary let binding. No, not unnecessary. Match data. Wait, actually, we need to iterate over the data for char or C in data, which is, wait, what? String is not an iterator. Yeah, you're right. Data that char. So every character has a meaning. In this case, and here we will have our user data. So for now, a user is going to be pub struct user current node. It will only have current node, which is like what, 2 zeros. Was that the way? No. This 2 zeros. Yeah. What? Oh yeah. I32. Yeah, you're right. Okay, I got it. But this can only be U8. So this is better. Current node, and nothing else is required at this moment because this is just an algorithm. So, and the board is going to have a what? Top user, or actually let's start with bottom. No, top user is a user, and bottom user is a user too, but player is a better name. So let's implement this for users, actually players too. Okay, match C. This will panic, right? Oh hell. Match. Oh, sorry. Okay. This loop never actually loops. Okay. But for A, let's print line A. So this is better. Okay. How do we define a cursor here? We could actually enumerate in this case. Like how? Let's see. For C or I and C in data that's split. Wait. x/n that enumerate, right? This is usize and this is a string. Split. Okay. So we have right now a y value which is 0, or actually this is the y value, right? And this is the rows, right? For let's see, C is good. Yeah, C is good. And X in data chars enumerate and print line. But this still is not a cursor because we have like unnecessary characters like spaces. So we need a real cursor here. This makes this function useless, or this loop useless actually. Let's continue with this one and let x and y is 0 to 0 to 0. Let cursor, or current node is better. Current node is some pixel, right? Oh, wait. Do this like option, and it is none at the moment. So when we see x if this is not the first, like how can we do this? Let mute, by the way. How can we do this, by the way? Let mute, like this. Oh yeah, it's like this. Okay. This is not defined in Rust. Okay. And before doing this one, does x actually do something? And do not increment y value, for God's sake. And if we see a new line, it will increment the y value by 1. And actually the only thing that x does in here is incrementing the x value. So this is, oh, this was really good. Definitely intended to do this one. Okay, and now what? Do we need any cursor stuff in here? I guess no. So let's see. In here, So these all rows and columns are created by default, right? So we don't need to do anything in here. I'm thinking in Go, because I implemented something like this in Go for image compression. For columns and rows, it was like hell. But at the end of the day, I think this is better. We just go through these lines, past. If we see a space, do nothing except current node is equal to none. So let's make this mutable. If is not defined, like how do we, if let sum, yeah. Let's see, board y and x is equal to none. Board that rows. Oh, we should use ref, right? Font pixel. Yeah, then do this. What does the compiler say? Consider clone. Implementing clone. I don't want to implement clone. It is easy though, but I don't want to. It clone this value. Okay, I know this, but like, what do you say about this one, by the way? Cargoran. Do you suggest anything? Yeah, it can't be dereferenced. You're right. Ref, yeah, so okay, you do the same thing. But what about this? So we can't do this one. Okay, this is possible. So yeah, this is basically this. If sum, if, okay. Oh yeah, I didn't know that we can do something like this. But this makes sense, right? It takes, which makes the x none, and at the same time we don't get bitten by the brow checkers. Okay. And if let's see. Or actually do something like what can we do this here? So 0, and now it's 1, and now it's 2, now it's 3, and now it's 4. And in 4 we saw this. Let's start with 1. So the x and y indexes are correct at this point, right? Because we assured that it is in by doing this one. So when we reached something like this one, and then why do we do this actually? I'm just going to disable this one for a while, like it's going to be empty. When we see 1, board y and x, oh no, board that bottom user is bottom user that current node is y and x, yeah. Or actually player index x u8 y u8. Can we do this? Okay. Yeah, we implemented almost everything. It took even shorter than I thought, which is a good thing. If we see this, do what? Board that rows y x that what wait oh okay. So we can't do this, right? Okay. So this is not U8 then. U size, right? It requires a U size. Let's see. Wait a second. U size, yeah. Now what is the problem? But this is pixel. What is going on? Okay, okay. It was about I was recording a macro at that point, so pixel, come on. Rows y and x dot left wall is true, and if you see what this one top wall what left bottom, no, right, not right, left. Let's see, top bottom left. Okay, top bottom left. Top true, bottom true. Okay, so I guess this is all. Yeah, this was simple, yet it take some time. Yeah, we thought about the implementation of this stuff, so let's create a file to test this one out. Yeah, this is exciting. And to test this one out, let's create a function to string. This takes self and returns a string. For row in self that rows let well is string new. That has nothing in it. Okay. And at the end, while that well is equal to what? Like, can we do this? Mismatch types. What is going on? Oh, okay. Yeah, return it. Okay. We have to clone here. Right. Or actually just two owned, right? How do you create something that is not borrowed? Why this didn't work? I'm not sure what this didn't work out. Let's search Rust 2 owned doesn't own self. This is not the issue. Chat. Let's go. Oh, what did you do? And let's remove this one. Wait. In Rust I have this function. The problem is I want to make self owned value by defining one, but here a is not a owned value. It is still borrowed. So no matter what, we need to implement clone. Not clone. Copy, I guess. Clone. Self is a struct I defined, and it doesn't get owned when we run clone. Okay, let's see. Let's check this out. What board? Let's go to board. Oh yeah, it was really that easy. But actually we can use copy, right? Clone copy. But let's go with clone. We can't. Okay. Copy. Oh, to implement copy, we need to implement clone. Okay. So let's go to player. Clone. Copy. Copy cannot be implemented for this type. Okay. Okay. Row. Pixel. Let's go to pixel. Yeah, we can also implement copy, right? Yeah. Yeah, okay, got it. But let's not just implement copy. Okay. Okay. For each pixel, let's see. We'll test if user 1 is here, user 2 is here. What implements either? If not, only X, right? So that's it. For our tests, I think this is the best way to implement this one. But actually, I really want to test this one out first, parse from string, because it's gonna take some time. And since we... What is going on? Yeah, okay. Since we implement this one, let's try this out. Let create a file called parse and copy everything here from there. Parser. What? Oh. Okay, that was a little scary. So this is not needed, right? Okay. Oh hell. Unexpected character. Okay. Not parser. Let's go to parse. We've added all of these, which looks terrible, by the way. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Three, 4, 5, 4. Yeah. This is just more clear. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's, in our main, let's open the file. std.fs file, open. Path is going to be what? Parse dot. Okay, parse.txt. Let's unwrap it for now. This is a file now, and let's board. Let nodes equal to not display, but let's include debug. So implement debug debug, yeah, board from string file read to string. Oh, no. Let file text is going to be what? Vector? What is the problem? Come on. My language server died. Come on. That unwrap, please. Okay. So first of all, let's print line file text. Okay. Yeah, it's successful. Then file text. Nodes. Print line. Nodes. And don't print file text. Let's see. Panicked. What? Why is our indexes? Okay, yeah, I get it. Make x to equal to 0, please, and then cargo run. Yep. We got a little problematic stuff, so we need to implement what was it? Stringy. Okay, I'm gonna do it, but after I come back from bathroom. So see you there. Okay, I'm back with my tea. So, I'm a little tired. Okay, so no matter what, we need to implement this stringify, but we'll implement it as debug. Debug? No, not debug. Display. Yeah. For board FMT. Okay. For mother. Let's see. How do we implement it? Right. What do we use? I guess we can. I guess we can do this, right? Okay. So let's take everything we have in here and pass it there. Okay. Let mute well. So let's see. If pixel, or actually if board that top user that player index actually this is shitty, to be honest. Just do something like this. Yeah, this is just better. Okay. Top player, or let's start with which one was the top, by the way. Instead of 1 and 2, let's use 1 and 2. Bottom, like B and T, bottom and top. This is better, right? So let's change to top, bottom. Okay. If board that top player equal to player. No, this is bad. This is bad. We need enumerate in here. Yeah. Let's wait a second. At the end of each for loop for row, let's add a space. Print line top player. Oh yeah, use of print line. This is just bad. Value, add 2 to value, right? So in this case, we will have B, by the way, not top player. No, T. And the for bottom player, we'll have B. And else if is going to be here. So if we have a player inside, by the way, uppercase, yeah. Okay. If we have the player, we'll have T at the beginning, right? Okay. We check these two in here. But how can we define? Oh, we can say like, let is empty, right? It's going to be true in the beginning, and it's going to be immutable, and we'll say it is false if we use either of these two things. False. Yeah. Just like that. Okay. And if pixel that top value, we will add what was the top? Oh, it's this, right? Top, bottom, yeah. And if we have bottom, then we'll add this guy, and else, no, not else. And if we have left, it's going to be U. And I didn't like this style of this code, but we'll fix it. And if is empty, we are going to add value to x, add x to value. Did we miss something else? We have spaces and new lines. Yeah, this is all. So this is the moment. For quite some time we are writing this code, but now it can show us if we are right or wrong. Let's see. Bam. Oh. We need to write this well. That's to as str. Yeah. Oh yeah, we got some stuff. What we need to do is here at the end we need to set isEmpty to false. But I can't see B. I can see the value B. Why is this? Why is this? We have it in here, but I can't see it. Oh yeah, top player. Okay. Same as this. Oh yeah, you're right. So what is the problem? Is this the problem? No. Okay. First of all, let's just set isEmpty to true. So okay. So everything is correct. If you don't count the B, the bottom value is not here for some reason. I don't know what. Value is plus equal to B. Board bottom player X bottom player Y is equal to X and Y. What is the problem? I think the problem is maybe here. Top player, bottom player, player X, Y. Let's write it in debug mode. Let's see. Or actually, let's write the bottom player. Let's play. What? Let's go. Why you can't find the top player? Because this is not public, right? Yeah. Let's make everything public. Okay, and we can now write bottom player. Okay, let's go. 4 and 9. Is this true? RC 0, 1, 2, 3, 4, and 9. 0, 1, 2, 3. Yeah. By the way, we have one line. Oh, okay. The problem is we gotta have 9 to 9, right? Yeah, we had 9 to 10. So the problem was that this is too big for our canvas. The problem was just that. Now I guess I'm going to be able to see our board correctly. Oh. Yeah. This was it. So for now we have some functions to test if we did something right or wrong. This is just it. I want to test also this one. Like what happens if we have something like that. Okay, this is correct. Let's test this one. Yeah, this is correct. Okay. Everything is right at this point. So, as I said, currently we have two functions to check if the stuff we are giving and taking out is correct. This is all. We didn't implement any algorithm that we can use in the game. But this is a great like implementation because you know everything is not going forward. Everything is not about going forward. sometimes to take a step further, you need to take a step backwards. Okay. And here's the part that I was scared of, which is implementing the algorithms. First, we need to check. Like, let's go to the board. We need some functions to check if we can go somewhere. Like if the move is valid for the player. Let's write these down, right? Is the move valid for player, for the given player? Hop. Let's make it bigger. Which means that, let's see. Which means that, like if the player is here, for example, and if he tries to go there, this is not valid. But is this required in the algorithm that we wanna implement? No, it's not. This is important for the game itself, but not for the algorithm. And we are, for now, we are trying to implement the algorithm itself. So this is something for the game. Just for the game. Is a valid move? Is there any actually, you know what, this is useless. Let me tell you why. Because in the user's perspective, like, think this like chess. He'll see something like that. Like, there's a 44 to 44. There's going to be a ellipse, and there's going to be an ellipse, and there's going to be an ellipse, and there's going to be an ellipse. So user will choose one of them, and so there's no illegal move in this context. We will only check if there are any wall here. If is there any move at the path, at the road, at the path, okay, which takes player, move, and this is all. Yeah. So let's try to implement this in text. If we choose top, oh, by the way, oh yeah, we'll not have bottom. Yeah. How did I not think of this before? Let's remove the bottom. This is going to be painful, but let's go. There's only going to be a top and left, right? Yeah, just like that. So this is going to be illegal right now. Yeah, it will panic because we have top and also we have bottom, but bottom is not defined. We can't use bottom. Oh wait. Okay. Yeah, just like that. Okay. For top, we will check if if the current, check if current pixel that the user is in has a top wall. For bottom, check if there is any pixel. Actually, check if the current pixel that the user, the current y value that the user have is bigger than 0. And actually, if so, if the y minus 1 is equal to 0, he wins. If not so, in does not have a top wall. Okay. Players y is minus equal to players y. Oh yeah, that's great. This is basically it for top. For bottom, we check this one. Check if, and let's where is this one? Yeah, it's here. Can we remove like, okay. Yeah, we can't do that. Oh yeah, we can, yeah, just a second. So we don't have a bottom anymore, right? Left and top. So let's remove bottom. Yeah, this is basically it. And make this untouchable again. Check if border rows y minus 1 and x that doesn't have a top wall. Yeah. Actually, this is not the win state for the second user. So we need to check each user too at this point. So let's remove the win state for now. We'll just implement the possibilities here. So, okay. yeah. Wait a second. Players. Why this is minus? Okay, players y is plus equal to players y. Players y minus equal to players y. So left and top and bottom is just like this. And for left, we also have the same check that we do in the beginning of each conditions, right? Let's implement this one. Left check if current x value that the user have is bigger than 0, and check if current pixel that the user is in does not have a left wall. Okay, and for right, let's copy this one. Check if current x value that user have is, let's see, not equal, yeah, okay, is not equal to border that rows 0 that len -1, right? This is just it, yeah. Check if current player that user no, this is right, this is not right, and we forgot the players x is minus equal to players x. Okay, so in here, let's actually do this one first. Check if border rows y and x -1, right? No, x +1. But let's think about this one. Bottom. I wanna go bottom, so I need to check the, yeah, okay. X plus 1 that left wall is false. Or let's say this the same way, or just let's say false. Player that x is, or just say players x is minus equal to players oh, what am I doing here? We'll just say 1. This is a minor mistake. Okay, so we go right, x is +1, go left -1, bottom -y, top +1. Okay, this is basically it. Now we can implement this one. For players, we'll have functions like move, right? Let's go. And actually, we also need to have stuff to define which border is which users. So this is a to-do. For now, just implement the player. Implement player. What happened here? Player. Pub function move. Enum move direction, which is top, bottom, left and right. Mutable self, expect the name. What? Oh, okay. Move to. Okay. Move is the you can't use the move name because it's in syntax. Like you can say move. This is used for closures in the language. That's it. Let's go. So we need also a direction, right? Direction is a move direction. So let's take a look at this algorithm here. And also we need the board too. Move to. So we don't want to implement the player at this point, right? Yeah. Implement board. Move to direction, move direction. Self is a move mutable. We need to define which user we wanna move. How can we do this? What is the best way? Move user. Is there anything we can do for this problem in the language? I'm not sure about this. Is there any way to let this function to take both border and player at the same time? I don't know. Enum. Let's create an enum for this. Public, by the way. Oh, we need to. Oh, okay. Pub enum moving user. Or like top and bottom. I think there's a better way to do this in the language because there are a lot of syntactic sugars. But for now, let's just keep going. User moving player, by the way. Move player. Player is a better name. Oh, wait. So let player is equal to self dot, oh wait, let player is match chosen player top, then return the self dot what top player, And otherwise, let's return the bottom player. No. Bottom player, right. Cannot move. Okay. Let's return a mutable reference to it. No, not here, but here. Okay. By the way, this returns a result. We'll think about it later. So we got the player. Let's implement the match statement. Match. Match what? Direction. Move direction top. Bottom. Left and right. Yeah, okay. Player that's y equal to border self dot rows right len -1 if this is equal to this, or what if the current player that the user if current pixel that the user is in, okay, or let's current pixel, let's take it here, let current pixel which is equal to board self rows player y and player x. Mutable reference to this is the current pixel. Top wall or so if we have a top wall, or if the y is bigger than rows length, then we panic. For now, illegal for how do we fix this one? Oh, okay. The problem was this, right? Why can't we do this one? Okay. Or otherwise, what? Self dot. Let's see. Player Players are mutable. Yeah, players is mutable. So yeah, this is it. So let's try this one out actually. Let's go. In main, I want to move board that move player. Chosen player is moving player bottom, and direction is moving move direction top. Let's mute. Let's go. Illegal top move. Why? This shouldn't be illegal. Oh, wait. So the bottom player. Let's print board bottom player. What? Oh, okay. So this is true then. But we got an error here that I saw, that I'm gonna say, which is this has to be in reverse order, right? Because if it is equal to 0, let's take a look at this. Like, let's go parse. Bottom user is going to be here. So it can't move to top. It has to be like that. Yeah, illegal top move, right? This is right. And if we do this, what? It is in reverse order. Yeah, it has to be like that. Yeah, this is true. This is correct. Oh yeah. Let's implement the same thing for bottom. Current pixel, but I guess we'll not take the current pixel. We can bottom pixel. Let's check if let's check first if player that y is equal to board self that rows that length -1. If this happens, just panic. Bottom move. And cannot find current pixel. Or player wait, self dot rows player dot y +1 and player that X has a top wall, then that's it. Then this is illegal. Yeah. Let's move to bottom. Where are you? Illegal. Why? Why? So if you try to move to bottom, we need to increment it. Let's see. If it is equal to the length of our list, or players y do we have top wall here? So this is also true. But if we have this, what is going to happen? Okay, yeah. We are testing out every possible solution without knowing, right? Let's try this one. Yeah, it's right. And let's try this one. We can't go bottom here. Yeah. Okay. X with this, let's try to go to top. Where is it? It's here. Moving player bottom, move direction top. Yeah, let's go. Illegal. Yes. Exactly. Let's keep it bottom. Let's try it. Okay. Okay, this is good. This is good. We have top and bottom. Let's try it once more. And now it is time for left and right. Okay. For left, if player that y is equal to 0, or current pixel, which is self dot rows. Let's implement this. Let's take this one. Current pixel left wall, then panic. Illegal left move. Or player that x is equal to minus equal to 1. Yeah. And for right, check this. Let's see, player, not player y, not top wall. Oh, no, top wall. No, not top wall. Okay, left wall. Let's see if player if it equals to 8. Okay, let's try this one by one. Right, so we have bottom. Let's put it here. Left. Oh yeah, let's move it to left. What? Oh, okay, we got a problem. It moved by 2. I'm running out of battery. Wait a second, please. Oh, fuck. Nothing happened, I'm fine. But just a second. Let me check OBS. Oh, this is my PC, by the way. Up. No. I guess it is like that. Or like that, maybe. Okay. Yeah, this is good enough. Let's see. 2. Oh, this is correct. This is just correct. Okay, or not. Oh. Oh no, wait. Oh shit, we have a problem. We got a big problem. Why? Why? Oh wait, this is correct. Yeah, this one is correct. For now, just remove moving stuff because we have a parsing problem. So this one is correct, but this one is not. Wait. No, print something, bro. Oh, what is going on? So yeah, we have a problem. What happens if I define the user here? Oh, wait. We have a parsing problem. Okay, I guess we need a cursor node here. Like the first one was true, I guess. But okay, this is enough for today. Uh, we implemented some stuff. Blah 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 blah. Move player. Okay, the moving functionality is true, but we have problems in parsing. Or do we have a problem in parsing or printing? I'm not sure about this. I'm not sure about this one because check the, you know what, check this player value. So, and let's make it simpler by this. Right? 2, 3, 4, 5, 6, 7. Oh yeah, we have a problem in parsing, not printing. Where is it? It's here. Okay. How can we fix this? We can define a node here. Yeah, let node option pixel or current pixel. Yeah. If we see a new line, wait. Board rows y and x is equal to current pixel if let some is okay, how did we get past from this? If okay, and in this case do this. If you see player, there's no problem with these guys. If you see these guys, we're not going to do that. Instead, current pixel that what top oh wait match some that wait, some well so since it's none, we can say left wall is false, right? This one might get skipped. What is going on? Oh, okay. Let's match this. Coding guy, hey, welcome. Current pixel match some current pixel is going to be none, and if it is a none, don't do anything. Match bindings cannot shadow tuple variants. Let's clone it for now. Borrow checker. Oh yeah, it's just that simple, right? This is good. I really like this syntax here. Actually, I think we should find, or they should find something just better. But okay. Top wall, none. Current pixel is some pixel. Do we need to use clone here from now on? No, okay. Or not. Okay. And let's go. What have we done? Wait a second. Match current pixel. If it doesn't exist in here, if it doesn't exist, we'll create it. And let's say false. Come on. What have we got now? Is this true? No. Why? I don't know why you're not true, my guy. Let's just take these two in here. I gotta go to bath. Coming in a second. Yeah, I'm back. Okay, so currently we have a small minor problem, but it's not that minor because, well, I can't find a way to fix it for now. So why our index is not true? Because let's see, 1 2 3 4 5 6 7 8 9. Value is true, so what? Length is true. X, Y, 2. Okay, anyways, I got tired. I think this is enough for today. 2.5 hours. That's great, that's good. So, thank you everyone for joining me while I'm coding.